You can look at one graph and come away believing autism suddenly exploded into existence. In the United States, about 1 in 31 8-year-old children in the CDC's 2022 surveillance network were identified with autism. Around 2 decades earlier, that number was closer to 1 in 150. That rise is real. But here is the part the graph cannot tell you. A rising diagnosis line is not the same thing as a biological condition suddenly appearing. And once you understand that distinction, the entire autism story changes. Think of autism detection like a radar system. Imagine standing beside an airport in the dark with an old radar screen. The equipment is crude. It only detects large aircraft flying through a narrow section of sky. Smaller aircraft disappear. Aircraft flying unusual routes disappear. Anything the operator was never trained to recognize may never appear on the screen at all. Now replace that radar with a modern system. Expand its range, improve its sensitivity, train operators to recognize more flight patterns, install more radar stations in more communities. Suddenly, the screen fills with aircraft. Did the radar create them? Of course not. But here is where this story gets complicated. Better radar can explain why you detect more aircraft. It does not automatically prove that the number of aircraft in the sky stayed exactly the same. That distinction is the key to understanding why autism prevalence has risen so dramatically. First, the number. The increase in identified autism prevalence is enormous enough that it demands an explanation. According to CDC surveillance, roughly 1 in 31 8-year-old children across 16 monitored U.S. communities were identified with autism spectrum disorder in 2022. In the CDC's earlier surveillance around 2000, the estimate was approximately 1 in 150. Put those numbers on a chart, and the visual is startling. The easiest interpretation is also the most seductive. Something new must have entered our environment and caused an enormous biological increase in autism. A chemical, a medication, a food ingredient, pollution, technology, vaccines, something. That sounds logical. But the graph cannot establish that. A prevalence graph tells you how many people in a population are being identified with a condition under a particular system of definitions: screening, healthcare access, clinical practice, record keeping, and surveillance. Change the system, and the number can change even when biology does not change by the same amount. This is our first radar problem. If you install more radar stations, you detect more aircraft. And autism detection has changed enormously. Second, the spectrum changed. One reason this topic becomes confusing is that people often talk about autism as though it were one single biological package. It isn't. Autism spectrum disorder describes a neurodevelopmental condition with substantial variation from one person to another. Differences can involve social communication, behavior, sensory processing, learning, language, movement, routines, and other aspects of development. Two autistic people can therefore have profoundly different experiences and support needs. Think about our radar again. Imagine the original radar operator was told to look for one very specific aircraft: large, obvious, flying low, moving along a predictable route. Anything outside that pattern might be missed. For much of modern medical history, our conceptual radar for autism was much narrower than it is today. Autism was not always classified the way it is now. Diagnostic concepts changed. Clinical awareness changed. Screening changed. Conditions that had previously been separated were eventually brought together under the broader autism spectrum framework. That matters enormously, because when the definition of what your radar is supposed to detect changes, your prevalence measurement changes too. People who might once have received another developmental diagnosis may now be recognized as autistic. People whose traits were previously considered too subtle may now receive evaluation. Families and teachers may recognize developmental differences earlier. Clinicians may screen children who would never have been screened decades ago. None of this means the diagnosis is imaginary. It means detection improved, and there is an important clue showing just how powerful detection can be. Third, geography exposes the radar. If autism prevalence were simply measuring one perfectly visible biological trait, you might expect similar populations to produce reasonably similar detection rates. But identified autism prevalence can vary substantially between communities. The CDC itself notes that differences in evaluation and testing practices likely contribute to this variation. Think about what that means. A child's underlying neurodevelopment does not transform because they cross an invisible county line. but their probability of being recognized can. One community may have pediatricians who routinely screen for developmental differences. Another may have fewer specialists. One family may live close to a developmental clinic. Another may face months of waiting, long travel, financial barriers, language barriers, or limited access to evaluation. Same radar target, different radar coverage. This is one reason you have to be extremely careful with the phrase autism epidemic. An epidemic usually makes you imagine something spreading through a population. Autism does not behave like an infectious agent moving from child to child. What has unquestionably spread is our ability and willingness to recognize it. That alone can move the graph. Fourth, we started finding people the old radar missed. Consider another striking pattern. Autism has historically been identified much more frequently in boys than girls. In current CDC surveillance, boys are still identified more than 3 times as often as girls. That difference could involve biology, but detection also matters. If clinicians build their mental model of autism around the people historically diagnosed most often, people whose presentation differs from that model become easier to overlook. Imagine training an airport radar operator using thousands of examples of one aircraft shape. Eventually, the operator becomes exceptionally good at finding that shape. But another aircraft with a different profile may repeatedly pass through the same sky unnoticed. As understanding improves, those missed patterns can become visible. That can raise prevalence without creating a new person. And this principle extends beyond sex differences. Awareness matters, education matters, healthcare access matters, diagnostic criteria matter, social stigma matters, whether parents know an evaluation exists matters. The number on the graph is therefore not simply biology. It is biology filtered through a detection system. But now we reach the most important reversal in this video. If better detection explains an important part of the increase, does that mean autism is merely a diagnostic invention? That conclusion fails for the opposite reason. The radar may change. The aircraft are still real. Fifth, underneath the diagnosis is biology. Autism is not simply a label attached to behavior for convenience. It is a neurodevelopmental condition, and decades of research have increasingly connected autism with biological processes involved in brain development. One of the clearest places to see this is genetics. But forget the popular idea that scientists are searching for the autism gene. That is the wrong mental model. Instead, imagine the brain as an enormous orchestra being assembled while the body develops. Thousands of biological instructions influence when different players enter, how loudly they play, which sections communicate, how connections form, and how the entire system develops over time. There is no single conductor called the autism gene. There are many genetic contributors. Large-scale genetic research has identified more than 100 genes with substantial evidence of association with autism in major studies, and many implicated biological pathways relate to gene regulation and neuronal development or communication. This changes the question. Instead of asking, which gene causes autism, imagine asking, which combinations of biological instructions can alter the developmental trajectory of the brain? Now the complexity makes sense. Different genetic changes can affect different biological pathways. Different combinations can produce different outcomes. The same broad diagnosis can therefore contain people whose developmental biology is not identical. That is exactly what you would expect from a spectrum. One radar category. Many biological routes into it. Sixth, genetics does not mean destiny. When people hear that autism has strong genetic influences, they sometimes picture a simple inheritance pattern. A parent has an autism gene. They pass it to a child. The child becomes autistic. Biology is not that tidy. Some genetic variants can be inherited. Other genetic changes can arise newly during reproduction and early development. And autism-associated genetics involves many variants and pathways rather than one universal mutation shared by every autistic person. That complexity helps explain something families often find confusing. Autism can cluster in families, yet two siblings can have very different developmental profiles. Someone can be autistic even without an obvious family history. Traits can also vary enormously in how they appear. The orchestra analogy helps here. Changing one instrument does not necessarily change the entire song in the same way every time. The result depends on what changed, when it changed, and what else is happening across the system. This is also why autism should not be reduced to one outward behavior. The diagnosis is based on observable developmental and behavioral patterns, but the biology beneath those patterns can be complex. And that brings us to timing. Seventh, the story begins early. When parents notice developmental differences at a particular age, it is completely natural to look backward and ask one question. What happened right before this? Maybe a child was developing in a way that seemed typical, and then differences became much more obvious. The human brain is built to connect events. A happened, then B happened, so A caused B. Sometimes that reasoning saves your life, but in developmental biology, it can also mislead you. Research into autism points toward processes beginning during early brain development, including prenatal development. That means the moment a developmental difference becomes visible is not necessarily the moment its biological foundations began. Return to the orchestra. Imagine one section of the orchestra has been developing differently from the beginning, but that section does not play an important part until halfway through the composition. When you finally hear the difference, you might assume something happened at that exact moment. But the developmental pathway was already there. Visibility and origin are not the same thing. That single idea helps explain why autism has attracted so many false causal stories. Parents notice something. They search for what happened nearby in time. Humans are pattern-finding machines, but timing alone cannot establish causation, and nowhere is that lesson more important than with vaccines. Eighth, the vaccine myth. Vaccines have been blamed for autism for decades. The claim became culturally powerful partly because early childhood vaccination and the age when developmental differences may become noticeable can overlap. That creates an emotionally compelling timeline. Something happened, then something changed, but temporal sequence is not proof of biological causation. If you turn on your radar at 9 o'clock and detect an aircraft at 9:01, the radar did not manufacture the aircraft. It revealed something that was already there. The vaccine autism hypothesis has been examined repeatedly, and the overall scientific evidence does not support a causal relationship between vaccination and autism. That matters because this is not merely a semantic debate. When we confuse coincidence with causation, we stop investigating the mechanisms that actually deserve attention, and autism biology gives us a much more complicated picture than one external trigger. Genetics matters. Early brain development matters. Developmental biology matters, and environmental factors may interact with those systems in ways scientists are still trying to understand. Which brings us to the hardest category of all. Ninth, environment does matter, but that sentence is easy to abuse. Whenever researchers find that an exposure is more common among autistic children or their parents, headlines can turn that association into a cause almost overnight. That is not how causal science works. Suppose researchers observe that exposure X occurs more often in one group than another. There are several possibilities. X could contribute causally. The underlying biology could increase both X and the outcome. A third factor could influence both. The association could change after researchers account for family, socioeconomic, genetic, medical, or geographic differences. Or the relationship could be real, but far more complicated than a headline suggests. This is called confounding, and autism research is full of situations where it matters. Imagine looking at our radar map and noticing more aircraft near wealthy cities. You might conclude wealth somehow creates airplanes. But wealthy cities may have larger airports. They may have more radar stations. They may have more passengers. They may sit along major flight routes. One correlation opens 10 questions. It does not close the case. This is why lists claiming that pollution, pesticides, medications, infections, parental age, the microbiome, or some modern chemical causes autism need careful scrutiny. Some exposures and developmental circumstances are legitimate areas of research. But an association is not automatically a causal mechanism, and even when a factor genuinely changes probability, a risk factor is not destiny. This distinction protects the science from becoming a blame machine, especially for parents. Pregnancy research is particularly vulnerable to this problem because almost anything associated with child development can become transformed into a message about what a mother supposedly did wrong. That is scientifically reckless. Complex developmental outcomes cannot be reduced to a single meal, stressful day, medication decision, or ordinary parental behavior without strong causal evidence. The correct question is not, who should we blame? It is, what mechanism does the evidence actually support? 10th, why one culprit is so attractive. Your brain hates complicated explanations. If a graph rises sharply, you want one variable that rises beside it. Find the villain. Close the case. But autism is almost the perfect example of why biological systems resist that kind of storytelling. You have a diagnostic category that changed over time. You have awareness changing. You have screening changing. You have healthcare access changing. You have social attitudes changing. You have people previously overlooked now being recognized. Underneath that, you have complex genetics. Underneath that, early developmental biology. And around all of it, you have environmental conditions that may interact with biology in ways that range from well-supported to barely understood. One culprit is emotionally satisfying. A network is scientifically more realistic. Think about our radar screen again. If the number of dots increases, at least 3 things could have happened. There could be more aircraft. Your radar could have become better at seeing aircraft. Or both could be happening. The graph alone cannot tell you which. You need other evidence. And that is the trap hiding inside the phrase, autism rates are skyrocketing. The statement describes a measurement. People often hear it as an explanation. It isn't one. 11th, what can we actually say with confidence? We can say identified autism prevalence has risen substantially. We can say changes in diagnosis, recognition, screening, and evaluation contribute importantly to what gets counted. We can say autism represents real neurodevelopmental differences rather than a fictional label created by modern medicine. We can say genetics plays a major role in autism biology, with many genetic contributors rather than one universal autism gene. We can say research points toward developmental processes beginning early in life, including before birth. We can say environmental and developmental factors remain legitimate areas of investigation, but association must be separated from causation. And we can say, the evidence does not support vaccines as a cause of autism. Notice what we cannot honestly say. We cannot look at one prevalence graph and calculate exactly how much of the increase is biological. We cannot declare that better diagnosis explains every additional identified case. We cannot choose whichever environmental exposure scares us most and call it the missing cause. And we cannot pretend autism is one biological condition with one pathway that will eventually produce one simple answer. That uncertainty is not a weakness of science. It is science refusing to invent certainty where the evidence does not provide it. 12th, the question itself may be wrong. Why does everyone suddenly have autism? Nobody does. And autism did not suddenly arrive. What happened is that the radar changed dramatically. The category became better defined. Awareness increased. Screening expanded. More clinicians learned what to look for. More families knew evaluation was possible. People whose presentations might once have gone unnamed became visible. At the same time, science began seeing beneath the radar signal. Genetic studies revealed extraordinary complexity. Developmental research pushed the biological timeline earlier. Researchers began separating factors that merely travel alongside autism from factors that might actually influence developmental risk. And that work is unfinished. That last sentence matters, because there are 2 equally dangerous ways to tell this story. The first is to say there must be a new hidden toxin causing an autism epidemic. The evidence does not justify that conclusion. The second is to say the entire increase is simply doctors diagnosing more people and there is nothing left to understand. That goes further than the evidence allows too. The scientifically useful position sits between those extremes. A substantial rise in identified prevalence can occur because your detection system changed. Biological and developmental research can simultaneously continue asking whether other contributors influence underlying prevalence or risk. Those ideas are not contradictory. They are what happens when you separate the radar from the sky. And once you do that, another question becomes more important than the original one. What should autism research actually be trying to accomplish? If you begin with the assumption that autism is an invading disease, the obvious mission becomes finding something to eliminate. But autism is a neurodevelopmental condition encompassing people with enormously different characteristics and support needs. Some autistic people require substantial lifelong support. Others live independently. Some experience serious co-occurring medical or developmental challenges. Others primarily encounter difficulty because environments are built around different communication, sensory, or social expectations. One label cannot tell you an individual's entire life. So understanding biology still matters enormously. But understanding biology does not require treating autistic people as mistakes. Researchers can investigate developmental pathways. They can investigate genetics. They can investigate co-occurring health problems. They can investigate why some people need more support than others. They can improve communication tools, education, healthcare, accessibility, and quality of life. The radar should not exist merely to count dots. It should help us understand the people those dots represent. And this is where the prevalence graph looks different. At the beginning, that rising line looked like evidence that something terrifying had suddenly happened to children. Now you can see everything compressed inside that line. Changing definitions, changing awareness, changing screening, changing access. Previously missed people becoming visible. Complex genetic architecture, early neurodevelopment, possible environmental and developmental contributors still under investigation, and decades of misinformation trying to turn uncertainty into a single villain. The graph is real. The simplest interpretation isn't. Autism did not suddenly materialize when the numbers began climbing, and a diagnosis does not create the neurodevelopmental differences it detects any more than radar creates an aircraft. But better radar does something important. It makes previously invisible people visible. The next scientific challenge is separating changes in detection from changes in underlying biology without pretending we already know every answer. Because the goal is not to win an argument about whether autism is increasing, the goal is to understand what the number actually measures, what biology can genuinely explain, what remains uncertain, and how that knowledge can better support autistic people. So the next time someone shows you that dramatic rising autism graph and says, "Something must have suddenly caused this," remember the radar. Ask whether the sky changed. Ask whether the radar changed. Ask whether both could have changed. And most importantly, ask what evidence can actually distinguish between them. That question is less dramatic than finding one villain, but it is much closer to how science works.